Alright, so we're on lesson 4, guys. So we talked about what imaginary numbers are and what complex numbers are and how to, just simplify and multiply and stuff with them. Today we're going to talk about solving equations that have square roots in them. So we're going to start by talking about what domain is. That's a vocabulary word. I don't know if we've talked about domain in here yet, but we're going to talk about it now. I don't know if we've talked about it this year or not, but anyway, we are going to also look at specifically what is the domain of square root functions, and then we'll look at solving equations. So that's our goal for today. So first of all, let's talk about what domain is. The domain is all the possible values for x. Some functions can have, you can plug anything in for x that you want to. So like, for instance, on that first example there, 2x minus 3, there's no reason we can't plug any number we want to in there for x. It'll work no matter what. But with some functions, there's limitations. So for instance, I could plug in 4 for x here, and I'll get an answer. It's 2. You can plug in 2. There's nothing wrong with that. It's just a really weird number. I don't know what it is off the top of my head, but it's 1 point something. What you can't do is you can't plug in a negative number. Now, because that gives you what's called an imaginary number, and when we're talking about domain and range, we're only looking at real numbers, the other numbers, they're not the imaginary ones. So this is outside the domain. So you're not allowed to plug anything in for x that will make the part under the square root become negative. You can't have a square root of a negative. Okay? So domain is what are the possible values of x for a given function. Some functions, the domain is all real numbers. In other words, you could plug anything in you want to. Some functions have limitations. Okay? Like this one down here, x can only be positive. It can only be greater than or equal to 0. It can't be anything else. You can actually see that on the graphs too. When you graph these functions like 2x minus 3, that would look like this. Notice it goes in both directions forever, and there's no holes or gaps in the line. That means no matter where you're at on the line, you'll always have an x value. Okay? But if you consider this function, the graph of this one, which we'll look at on Monday how to graph these, they look like that. Notice that it doesn't exist on the left side of the graph. There's nothing over there because that's where all the x values are negative. So the graph doesn't even exist over there. So you can kind of see that that's the restrictions there. So domain is all the possible values for x, and square root functions have limitations. All right, so that's going to be our first thing that we're talking about there. So what we just talked about was that part underneath of the square root. That's called a radicand. Now, on the example I just gave you, the radicand was x. But it doesn't always have to be just x. It could be a lot of stuff, like it could be 2x minus 5. That's the radicand now. The part that's under the square root is called the radicand. And what we discovered is that the radicand has to be positive or 0. The way that you write that is like that. So step 1 to finding your domain is to take your radicand and make it greater than or equal to 0. Okay? After that, you solve for x. And what did you get for x? That's telling you what x is allowed to be. In other words, it's telling you what the domain is. So you have 2 steps to find the domain. Write out this little inequality here and solve for x. All right, so we'll go ahead and get started on that. We'll come back to that slide in a minute. I think this is on the back side of your notes. All right, so in this case, remember we said that step 1 is to take your radicand and set it greater than or equal to 0, right? So what's my radicand? Well, my radicand is everything that's under the square root. So x minus 2 needs to be greater than or equal to 0. And then we're going to solve for x. So that's step 1. Now step 2 is solve for x. So to solve for x, what would I do? Add 2 on both sides. and I've got x is greater than or equal to 2. So this is my domain. This is telling me what, remember, what's the definition of domain? Domain is all the possible values of x. What is x allowed to be? X can be anything that's bigger than or equal to 2. If you were to try to plug anything else in that wasn't bigger than or equal to 2, you'd end up with a bad answer. Can you guys give me an example of a number that's not bigger than or equal to 2? 1 or negative 1. I'm going to go with 1, a little bit easier. But I just want to show you don't have to write this part. But let's say I plugged in 1. What's 1 minus 2? And that's an imaginary number, which is not part of the real number system. So that's outside the domain. You're not allowed to plug in 1. But if you pick a number that's bigger than 2, give me a number bigger than 2. 4. If I plug in 4, I get a real number. The square root of 2 is a real number, so that's allowed. So all we've done is we just found out what is x allowed to be. All right? So let's go ahead and take a look at the next one here. So what we do is we take our radicand, and you don't have to write this step. I'm just doing this for teaching purposes where I write the word radicand. You don't have to do that. But what you do is you take your radicand and make it greater than or equal to 0. And I'll ask Aaliyah, what is my radicand on this problem? Yep, the radicand is the part that's under the square root. So it's 6 minus 2x. All right, now the solving here has an interesting little twist, so make sure you pay close attention. But let's go through it. What would we do first to solve for x? Now what? Okay, so let's back up. So I had one question over here. The one question I was asked is, where's the 5? Why did I not include the 5? It's not under the root. So the only part that goes here is the part that's under the root. Now, what was I heard another question coming up. No? Oh, okay. Good. So what do I do to get rid of that negative 2? We divide it. So let's do that. Now, something weird is going to happen here that you probably don't remember from Algebra 1, so I'll remind you. First of all, what's negative 6 divided by negative 2? Okay. Do you guys remember that when you divide by a negative number, the little arrow flips? Okay, so I'll make a note of that. But if I were you, I would highlight that. You know, it'd be like, okay. And then I would write a note saying, don't forget, if you divide by a negative.
Oh, divide by a negative? Only a negative?
Yeah. You need to flip the sign. Yeah. You only flip if you divide by a negative. So if you divide by a positive, you don't do that. Okay? So don't forget that. But now, according to this, what is x allowed to be? Anything that is less than or equal to 3. So in other words, the only thing you're allowed to plug into this equation up here are numbers that are less than or equal to 3. Anything else, it's not going to work. You're going to get imaginary answers that we don't want. Okay? So there you go. So step 1, make your radicand greater than or equal to 0. Step 2, solve. Watch out for dividing by negatives because you need to flip the arrow. Okay? Go ahead and do your student practices there on the other side. Go ahead and do the student practices. I'll give you guys a little bit of time. And by the way, it might help you to know that you might want to think of there as being a 1 here. That might help you. The thing? The 5 part?
The negative 5 on the last one.
Let me back up and see what you're talking about. Sorry, I just need to see it. Give me a second and I'll go back. Well, I want to go back. Okay, so you were saying something about this guy? Is that what you're talking about?
Yeah,
He has no skin in the game. We don't care about him. because the domain is only, we're only going to look at the part under the square root for that. So that 5 doesn't matter at all. All right, so there you guys go. I'll give you a little bit of time. All right, so let's go ahead and go back to my PowerPoint for a minute. Now, since x is only allowed to equal certain things, sometimes when you're doing algebra, even though you're following the rules, and even if you do everything right, sometimes you might get an answer that's wrong. And that seems like, well, that's just great. I hated math enough, and every time I do everything right, I still get the answer wrong. Unfortunately, yes. There's actually a really cool proof out there that shows that you can make 1 equal 2 by following all the correct steps, but there's a little sneaky thing and then somebody stuck in that's really hard to notice. And this is kind of like that. Even though you follow all the steps right, you could technically get a wrong answer, and what we call those is extraneous solutions. So like, let me give you an example. Let's just say you were solving an equation like this, and it wouldn't happen. I'm totally making this up, so it won't work right, but let's just say I solved it and I got something like x equals -10. Well, that would be an extraneous solution, because if you plug this in, you're going to get -30 take away 1, which is -31. That's not allowed. So if you ever get an answer that's not in the domain, then that's what we call an extraneous solution. Okay? And sometimes that can happen, and we'll see that happen at least once today. Okay? So let's go back, and now we're going to actually, now that we know what the domains of functions are, we're going to actually solve some equations here. So let's get started. I don't really like the 0 there. I'm going to change this. Let's change that to an 18. Matter, make it a -18 actually for me, please. Okay, so we have this. Now, when you're solving these, the first thing that you want to do is you want to get rid of outside numbers first. So what number's outside of the square root? Okay, now that -9 is multiplying the square root, and the opposite of multiplication is? So we're going to divide both sides by -9. So let's do that first. So that goes away, and now I have a 2 here. So step 1 is to get rid of all the numbers that are outside of the square root. Sometimes you'll have more than that. Sometimes you'll have like a number over here that's being added as well, but we don't, so we don't have to worry about that. But just want to show you, you want to get rid of any of the numbers that are not under the square root first. All right, step 2 is you want to get rid of the square root. And the way that you do that is by raising both sides to the second power. The second power is the opposite of a square root, so they cancel each other out. So step 2 is to get rid of the square root by raising both sides to the second power. Get rid of the square root by raising both sides to the second power. So I'm going to raise this side to the second power. I'm going to raise this side to the second power, because whatever you do to one side, you have to do the other. And on the right side, these cancel each other out, and so I'm just left with 7 minus m. And on this side, I have 2 to the second power. What's that? Okay. At that point, you should be able to just solve using our, basic 1 or 2 step equation processes that we learned in Algebra 1. Just get the m by itself by doing the opposite operations. So let's go ahead and solve. What would you guys do first here to solve this? Okay, so I would subtract the 7. I agree. That would give me, what's 4, 2, 7, 3. And then, now don't forget about that negative. He matters. That's there. That's a negative m. You could think of that as a negative 1 if it helps. Now, how do I get rid of that negative 1? Yeah, that's right. I'm sorry. Writing. But yeah, divide both sides by a negative 1. So I get 3 equals m. And that's the answer. Now, technically, what you should do is plug and check. Now, we've never done that before. We always could have done that back when we solved other equations. You could always plug it in and make sure you got the right answer. But with these kinds of equations, it's really kind of important that you actually do that because, like I said, it could come out to be an extraneous solution, one that's not allowed. So let's plug it in and see if it works. Ready? We said negative 18 equals negative 9. 7 minus, what am I going to plug in for m?
3.
Let's plug in our answer and see if it works. So first of all, what is 7 minus 3? What's the square root of 4? And 9 times 2? Does that work? We're happy. Okay? Yeah, I'll leave that up. I went a little fast, but all I did was I plugged in my answer to make sure that it worked. Yeah. Say that again? We did it ourselves. We did it because the goal was to get rid of the square root. So to get rid of the square root, you raise both sides to the second power, and that cancels out the square root. So it's kind of like, when you're solving an equation, like here. This is negative 1 times n, so we do the opposite to get the m by itself. Well, to get the m by itself when there's a square root, to get rid of the square root, you do the opposite, which is squaring it. Which one? Oh, here? That's the square root of 4. Yeah. Right. Let's do another example here. All right, so David, what's the first step when solving these square root equations? No, what's the first step that I had you guys write down? Get rid of the outside numbers. Do you guys see any numbers outside the square root over here? No, so we could skip that step. Adriana, what's the second step? Get rid of the square root by raising both sides to the second power. So let's do that. So that cancels that out. And that's 16. Kimaya, what's the third step? Did you write it down? Not sure? Oh. What, do you want to take a guess? So I can give you a point, or what would you do? Ignore the step thing, but what would you do to solve? Okay, so what we want, so the third step is to solve, but it's not dividing, but you're looking at the right kind of thing. What do you think there, bud? There you go. So when you got a number in the bottom, the way you get rid of it is by multiplication. You multiply both sides by 9. And that's going to be 90 plus 54 is 144. All right. I'll circle that. Edwin, what's the fourth step? plug it in, and the purpose of doing this is to make sure that it works, right? So let's make sure that it works, that we don't end up with any false answers. We don't want any extraneous solutions. So the square root of 144 divided by 9, well, let's do the division first. Guess what? It's 16. Yeah, very good. And what's the square root of 16? Are we happy? There you go. So we're happy. So this is the answer. It's not an extraneous solution. It actually works. It's a good answer. All right? And after some practice, you might be able to start to just be able to tell, like, oh, that's not going to work if I do that. Sure. You guys can go ahead and do the student practices, number 7 and 8 on the other side there. So go ahead and start student practices, number 7 and 8. Change this to what I'll do is I'll work this one out. So the first thing you're going to do is you're going to get rid of the numbers that are outside of the square root. So like the 9 divided by -18. Now you won't have to do that step here. There are no square root. The next step is to get rid of the square root. You can do that by raising both sides to the second power. Those are opposites. So, look at we just have something. So, you're the outside and just square it.
Especially if you already did it. But I think you know
Yes. Okay. Put up our answers for these so that the people watching the video can see them. All right. Let's go ahead and move on to our last set for the day. So for these kinds of problems, it's really important that you check the answer as well. So, but let's go ahead and do it. Now, do you guys see any numbers outside the square roots?
No.
No. So we're going to start by squaring both sides then. We'll go right into the second step, which is to square both sides to get rid of the square root. That gives me 3p plus 19. All right. Now another thing that's different about these kinds is that we have variables on both sides. I've got 3p on the left and negative p on the right. We're going to put them together, yeah. Now, I like to move the one that's smaller. So what's smaller, positive 3p or negative 1p? So what I'm going to do is I'm going to add 1p to both sides like this, putting the like terms together. So in this case, that's gone now, and this is now 4p. And now it's a two-step equation, right? So you subtract the 19. And last step. Denise, what do I need to do next? Check it. Let's check it. Especially, I think for these ones, that's especially important because a lot of times these types where there's a square root on both sides, These are the ones where you sometimes end up with answers that are extraneous. They're not allowed. Okay, so here we go. Square root of 3 times 15. Sorry, my bad. Negative 5. No, it's negative. Because negative 20 divided by 4.
So that's a check?
You do. I would highly encourage it because there's always going to be like one sneaky little problem where if you don't, you're going to get the wrong answer. So we have negative 15 plus 19. Now we can already see that this is going to work, so we're good. You guys are thinking Mr. Bailey's checking the step thing doesn't seem to be too useful. It just keeps working, so it's like, why bother? Well, there's going to always be that one that doesn't. You're going to think that's the answer, and then you get it wrong. So you got to check for it. It's there. All right, so I want you guys to do number 10. That's an example. I'm going to come around and check notes while you guys are working on number 10. But I'll give you the answer afterwards, okay? Yeah, so that one's going to be a lot like it. Similar stuff. Very similar stuff. Huh?
No.
0? Yeah, so just add the 3x and then equals 0. Oh. Oh. You want to get your x's together, so what I would do is after do one. Yeah. I would add the 3 on the other side. Plus x 1. So you probably did all the work right. Let me see. Yep. So the square root of the negative is not allowed. So we say 2. Oh, we're going to move this one here. No, you are right. You did all the work right, but you have to interpret the final answer right. Okay. Here. So, 3, 2. You have to move from this and this 5 to this. So you get 5x. Just subtract it. It is. Vote. You have to vote. All right, so guys, for this problem, you should have gotten x equals 1. But whenever you plug it in, you get this. These are imaginary numbers. What does that mean? No, so this is the one where you got to check for it, because it happens. It happens, and sometimes even, huh? The final answer? No, if you plug in 1, both of those become negative 3. Yeah. So that's no solution because these are imaginary. All right, and that's where we're going to call it for the day. Now, I had a few people come in tardy today, so make sure that you upload your notes so I can check them later because you weren't quite done. And then I'll give you guys your full credit. But the rest of you guys that check notes are good.
Mister, you check mine, you want me to upload?
You were pretty much there.
Yeah. I know I got to do Early, Miss
Number
Baby.
6, hold on.
Mr. Baby. We end it early.
It's a rally day.
Wait, we get out early?
No, it's a rally day. So every class is going to be a little bit shorter to make time for the rally.
We still get
Wait,
out
Miss.
at 9:42.
No, we get out of this class at 9:31.
Wait, Mister, when I do number 6, you gonna give me my full credit.
Wait, this is
Yeah.
Exactly, you trying to take my load, dang. Yeah, where the fuck where's snacking, Mr.
Huh?
Wait, where's snacking?
So the snack is still 10 minutes like always. They don't make that shorter.
And then second period?
But I don't know the time when it ends. Like, but
Second period?
well, I'll put it up here for you so you can take a picture.